Hello and welcome to a brand new episode of IET India's Walk the Tech Talk series season 2 in association with India Automated. In case you have missed out on any of our previous episodes or episodes of season 1 of Walk the Tech Talk series, then please do check them out on IET India's YouTube channel. Before we begin with today's episode, I would like to give you a sneak peek into the world of the IET. The Institution of Engineering and Technology is one of the oldest and largest professional society for engineers. Soon to turn 150, our mission is to engineer a better world. Our areas of focus include future technologies, future of mobility and transport, and future of work. In case you would like to become a member of the IET, all that you will need to do is send us an email at indiamembership@theiet.in. All right, now without further delay, I would like to welcome on screen your host for this series, Mr. Pranjal Sharma, the author of India Automated, for him to introduce the topic of discussion today and also introduce our guest speaker. Pranjal, I think he's facing some internet connectivity issues, but I am going to just go ahead and introduce our speaker guest. Hi, Vivek.
Hi, Ujjani. How are you?
I'm good. Very good to have you here. Vivek Mehrotra with us today. He's the Global Director, Digital Head of Digital and Architecture at Smiths Detection. While we have Pranjal back on screen, I would just like to let you go ahead and introduce your area of focus at Smiths Detection and also tell our audience today that our topic of discussion is going to be emerging tech in threat detection and security. So if you can shed some light on how Smiths Detection is helping in that context would be really helpful. Over to you.
Thanks, Ujjani, and thanks IET for providing me this opportunity. This is exactly what digital is, isn't it? When we wanted Pranjal to be here and, his network is working, and that's where we are all there to make sure that these disruptions are taken care. My name is Vivek, as you introduced, and I head the Smiths Detection Digital and Architecture Technology Organization globally, being in Singapore. I drive software and architecture decisions across all of our product to ensure product development is consistent across our product strategy. One of my main area is also to focus and oversee the strategy across artificial intelligence, machine learning, and deep learning across all of our products and organization. Beside this, I also drive cybersecurity, primarily the product security. If you look at it across of all of our competencies, I do have teams, primarily in different sites or different regions, who help me do what we want to do in this organization from a digital perspective. So that's about me. But and the topic of today is emerging technology in threat and security, threat detection and security. We are primarily a threat and anomaly detection organization. We do advanced threat detection in different market segments. We do it in aviation, ports and border, urban security, and defense. We manufacture sensors, scanners for detecting threats and anomaly in all these areas. The easier I can relate to or you can relate to is when you go to airport and you do passenger security screening or baggage screening, you get through the X-ray systems or CT systems to get the contraband, what could inside be the bags. And it happens both in our terminology, we call it as hold baggage screening, which is when you give your check-in baggage at the counter, and the big bags go behind the scene. It gets into multiple level of screens, and when you go to board the aircraft, I know today we are in those challenges of COVID, so not many of us are experiencing. But when we go to board the aircraft, we do passenger screening and as well as the cabin baggage screening, right? So those majority of X-ray machines across the world in the larger airport are us. We hold the largest market share in the world in this market. Ports and border, the sea ports and land border is another area where we provide high energy X-ray capability for screening what's coming inside the country and what's going out of the country, and that's where the government is interested in, and the customs department are interested in. Um, you know, Urban security, where we primarily focus for mass transit, or the larger events, the stadiums, threat detection around that, and defense, where we focus what we call it as CBRNE. So detecting chemical, biological threats, radioactive, nuclear, and explosive threats. We work with 200 plus countries, government of 200 plus country, and provide them these technology. So what we
Right.
do is actually certainly manage and develop these scanners or sensors across various different sites within our organization. Now what we're trying to do, how we can improve and provide value to our customer on top of what we do in terms of our machines with the help of digital. Because if you look at it, we collect a lot of data, and primarily, if you screen your bags or if you screen the containers or the vehicles which are crossing across the country, the images comes out, the X-ray images, similar to what happens when it is when a human body is scanned for a medical X-ray, right? So this data has a lot of information, and
Right.
what we do today is we use AI machine learning techniques to get the insight from these data, to understand what these data can tell us, primarily detecting some of the objects which have shapes, definite shapes, like weapons, lighters,
Hmm.
cigarettes, you
Hmm.
know, blades and all that thing. But the items which may not have shapes, we also go one step further and utilize, some of our, material science algorithm to understand, whether it is a narcotics or it's a chocolate or it's a liquid. Here we have
So,
Pranjal.
yes, we have Pranjal back. Pranjal, I was just filling in for you, but over to you now. So, I had Vivek introduce himself and also tell us a little bit about his area of focus in terms of the topic that we have today about emerging tech in threat detection. But now it's over to you. So, I'll be away. Please continue.
Thank you. Vivek, I got a good sense of what Smiths has been doing, but tell us what are the challenges now, because you're operating across, ports, aviation. There are so many new challenges coming up when you want to look at how to detect the problems. Now, what are the main issues that you're facing right now?
Yeah, I mean, look, this industry pretty much is a very traditional industry. If you look at it, when we do the security screening at ports or at borders or at the entry points, these have been pretty much traditionally very manual. There was a lot of human element into that. There's a lot of human intelligence involved into that. People sitting at the border, when they have been spending their life to screen what's coming inside the country or going outside the country, the intelligence is sitting primarily in their head. And that has become a bit of a challenge, that how we can automate some of such operations. And if I give you an example, and in today's world, and particularly, we are going through this pandemic, which has also increased a bit of a challenge on this side as well. If I give you an example of e-commerce, for that matter, where though passenger side of the aviation has taken a hit in this pandemic, but e-commerce or air cargo side was primarily going pretty well, and is going pretty well. If you are an e-commerce customer or e-commerce website, right, there are plenty of people who come and who list their products to you, and you fulfill their like what you see as Amazon fulfillment or Flipkart fulfillment orders, things like that, right? You don't know what's inside that parcel. Someone packs the parcel for you, delivers to your warehouse, and lists their item on your website, and buyer comes in, buys, and it is then your job to get it delivered to the seller. But at the same time, you don't know what you're delivering because you're not really opening the parcel, right? Now, you could be delivering the contraband. You could be delivering the dangerous goods, which you are not supposed to be delivering. And that's where the challenge comes from, that how do you really know what is inside that parcel, which is going from you from point A to point B, and given the amount of parcels which are coming in, or the trade which is happening, it's practically not possible to scan each and every parcel. One way to do it, that you could put it under the X-ray and you could see what is inside that, but it could be small to medium to large. So that's another challenge. Now, the question here is that how we could use AI or machine learning to create a risk profile of the shipper, based on the past anomaly, or based on the past record, or based on the current content. A lot of times, we have heard of places or cases where someone has ordered a mobile phone, but the brick was delivered, right? So how do we make sure that the credibility is maintained? Is where one of the biggest challenge comes in. I mean, this is just one part which I'm talking about. The other part is in ports and border. A lot of trade is happening through ocean route, and it is continuing to happen if you look at it. But it's not practically possible to scan each and every container, where millions of containers are entering the port of the country, each year. So the question here is that how do you scan the right container? What happens today? It is basically the intelligence is sitting on the custom officer's head, and he or she picks to it's kind of more like eeny, meeny, miny, mo, and pick this container and just put it under the X-ray, right? So that eeny, meeny, miny, mo has to now come inside the AI, inside the computer, or inside the system, in some intelligence way of system to tell that these are the right container, and then slowly increasing the percentage of a container to be, or vehicles for that matter, to be scanned. I think these are some of the biggest challenges which we see day in, day out, and we're working.
Well, one of the clear challenges which has emerged, and that's a question which came up as well, is in a COVID era, one of the biggest issue is bioterrorism. Now, this could be just virus sneaking in by default, or perhaps somebody does actively take steps to send in agents which are pathogens, or anything which can really cause a bioterrorist like activity. Now, how do you scan a microorganism? I mean, I'm sure there's no X-ray ready for that.
No, and that's a very good question. Pranjal, this is not an X-ray, and we use a range of technique to detect the threats. X-ray being very simple, or CT for that matter is another technique, but we use mass spectroscopy, to detect another type of threat. Very recently, from a Smith detection perspective, we have acquired an organization called Path Sensor. And Path Sensor has been very prominent in detecting, pathogens, variety of pathogens. They started off back in anthrax days, and we are very closely now working in terms of how do we see if we could do, with the current pandemic. So there are different technologies where we use those technology to detect these pathogens on the surface or in the air. And what we are trying to work, and this goes in our CBRNE portfolio, which I talked about earlier, chemical, biological, radioactive, nuclear, and explosive detection technique, in a way that, how we could have a handy or a handheld device which could detect a presence of such pathogen, in this case, the COVID-19 virus.
So, what are you talked about automation, you talked about AI and ML, but in the near future, what are the emerging technologies or applications which we have perhaps not seen or heard of, which you see becoming more popular? And across sectors, we're seeing that several such tools their use and deployment and their development has been accelerated. So can you give us a glimpse of the future of detection?
No, absolutely. And you look, there are two aspects to this. One certainly is improving the science and technology part of it. So using right amount of technique, or right way of detecting some of these threats. It could be X-ray, it could be gamma rays, for that matter. It could be, we're talking about mass spectroscopy. We are also focusing on some of the fundamental aspect of detecting. But the other aspect of it is, how we could use a software, or how we could use the data which is coming out of this hardware to get the insight of what is happening. Focus more on video analytics, for that matter. Biometrics. The airports, for that matter, are focusing more on becoming fully automated immigration systems, which means that your biometric data is integrated with your immigration data, and then you are completely, when you get in, you don't interact with anybody and just go out, right? So these are some of the areas where technology will go through. Technology is also going from using more and more AI and machine learning, but then using unmanned vehicles to do certain area, or certain type of threat detections where people cannot reach. Advanced robotics is another area where people are doing a little bit of a experiment to see how we can use robots to detect a threat in some of some of the areas where humans cannot go, right? So I think
it's also about scale, Vivek. What you're telling me is also, while at one level you're going deeper and deeper into microorganisms, at another level you're going large and at scale in terms of huge containers or big trucks, because everything has to be scanned. My final question to you is that in the era of IoT and sensors, I guess traceability becomes much easier. Is that IoT, is that helping you across all sectors?
Yeah. So if you look at Pranjal, IoT is primarily, connecting various of these devices together, and getting the data and getting some meaningful sense out of that data, right? That's what IoT is all about. So that's certainly helping us, and this is where the concept of all the buzzwords like AI, machine learning, blockchain, for that matter, starts to come in, and it starts to get together to help us understand what we are seeing in this data. So when you talked about scale, where it is a microorganism in one side, but it's a container on the other side, we use different technology to get to know what is inside. So high energy X-ray, for that matter, is typically used to understand what's inside the large container. Now,
Right.
there is an area of interest where you could be having a smuggling of drugs, or smuggling of narcotics, and as we are trying to improve the technology, on the other side, the smugglers are trying to become more and more intelligent, and they are hiding the things where technology cannot reach. And in an example which I will give you, in a refrigeration unit of a container, we have found people hiding narcotics and drugs, and they knew that we were not screening that particular piece of it, because it's not easily possible to understand, because it has a lot of component inside there. So these are some of the areas where we are focusing to work on, to see if we can certainly have a scale going forward. But it is a long evolving process. It just doesn't end here.
Sure. And before we end, a question has popped up, Vivek. Is there a technology that uses olfactory detection, like canines, for threat detection? Because that's something which needs to be scaled up. Because while canines and dogs can be used, but if you want to go at scale and perhaps speed, perhaps machines are required.
Yeah, no, absolutely. And this is another area where I think the industry is focusing on, because a lot of intelligence are sitting in humans' head or animals, and how do we transfer that intelligence to the system is of course with the help of what we can call it as a convoluted neural networks, CNN. And how do we train these CNNs over a period of time with the help of right data and detection technique, is where I think the focus has to be. If you look at it, more or less, the industry today is very much of a supervised way of training the algorithm, that you tell system that I am seeing a gun, or I'm seeing a knife, or I'm seeing a blade, and then system starts to understand that yes, this is the knife, or this is the gun, or this is the blade, and then over a period of time it detects the different types of knife. But what is needed is, how does this canine start to develop this capability, and how can we develop those neurons or those neural networks into the system, so that system over a period of time becomes smart. I think that's the probably a nirvana to the I would say that to the technology, but we are far behind there.
Right. Thank you, Vivek, for that. I think there's a lot to look forward to, and a lot of exciting, developments and innovations are around the corner. And of course, a lot of these things happen faster than we realize. But thanks again for joining us and sharing some of these exciting work in terms of threat detection that Smiths has been doing. Thanks again. Bye.
Thanks, Pranjal. Pleasure talking to you, and thanks, IT, for giving this opportunity.